Aloha, Richard Halverson here, and we are doing graphs. Today, I'd like to go over the section on directed graphs. So let me share my screen. Okay, so we are going to go through this section on directed graphs in this video. So you should read this read it, go through these participation activities, and we've all seen graphs, maps of graphs. This is directed graph examples. This looks like catalytic cracker. I don't know what that is. So anyway, road maps, the streets have directions and so on. Here's a directed graph that represents connections between items, web pages, could be airline routes, so on. The graph looks like this, except for the edges have arrows. So make sure you understand. Oh, and the definition of adjacency is slightly different. B is adjacent to A. It says right here. B is adjacent to A, but A is not adjacent to B. Okay. A is not adjacent to B because you can't go from B to A in one step. But B is adjacent to A because it only takes one step from A to get to B. That's what adjacency means. All right, so make sure you understand that. Paths and cycles. Of course, a path is a valid path following the edges and the directions that they're designated. A cycle is when you start and end at the same vertex. So with directed graphs like this, you can have A, D. No, you can't go back to A, can you? Because there's no you can't. There's no cycles in this graph because you can't. But in this one, there is. You can start at J and go to N and go to K and go back to J again. You can start at N, you can go to P, you can go back to M, you can go back to N again. So that's a cyclic graph. And here's an example of cyclic directed graphs regarding kidney transplants, and I guess maybe they really do this. If you want to donate your kidney to a loved one, and but they're not compatible, there could be some other, somebody else who wants to donate their kidney to their loved one, and they're not compatible, but maybe yours is compatible with their loved one, and their loved one is compatible with your loved one. And anyway, so this shows a graph of how something like this might work when you have multi-patient kidney transplants. So anyway, so this is directed graphs, cyclic and acyclic. Make sure you understand the concepts. Let's do this challenge activity. Okay. Consider the following directed graph. Identify the vertices that are adjacent to A. So what vertices are adjacent to A? Well, D and E are. D and E are adjacent to A. A that are adjacent to, okay, so it'd be D and E. Just to confirm that, let's go right back up to the top here so you don't get them mixed up, flipped around. In this example, B is adjacent to A because you can get to B from A. So that makes B adjacent to A. You can get to B from A. D is adjacent to A because you can get to D from A. Okay, so I got the direction right. B, what what vertices are adjacent to B? Let's see, you can't get to any other vertex. You can't get to any other vertice from B, so I'd say none. And what vertices are adjacent to D? Looks like C and B are. C and B. I'm going to put B and C because I don't want to. B, C. B and C. Okay, how's that? Very good. Okay, what's next? Consider the following directed graph. Which of the following are valid paths? B, B, B. Yes, that's valid. B, B, B. How about C, B, B, D, A? Yes. You can go C to B, go B to B. Then you can go B to D, and you can go D to A. So this one's valid. A, C, B, B. Nope, can't go back to C. You can't go from B to C. So no, this is not the valid one. A, B, B. No, you can't go from A directly to B. There's no line there, so that's not valid. A, no, there's no, you can't, A can't repeat. There's no repeating for A. D, A, C, D, can't go from D to B. D, B, can't go from B to B, so that's not valid. All right, I think it's just those two. Very good. What's the next one? Which of the following are valid cycles? We're talking about cycles now, so that means you got to start and end at the same place. This one doesn't start and end at the same place, so that's not valid. Let's see. Let's start with this one. D, B, A, A, D. D, B, A, A, D. Yes, you can. This is possible. How about this one? C, D, B, E, C. C, D, B, E, C. Oh yeah. C, D, B, E, C. That's a valid cycle. What about this one? Oh yes. A, 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 A. Yes, that's valid. How about this one? D, B, C, C, D. Oh, C, C. There's no loopy loop on C there, so we already know that's not valid. How about B, C, E, B? B, C, E. Oh, can't go from E to B. Can't go from E to B, so that's not valid. And this doesn't end with the same vertex that it starts with, so that's not valid. All right, what is this? What did I do wrong? C, D, B, C, D, B, E. Can't go back to C. Can't go from E to C. Was I thinking? Did you catch that? All right, I'm going to do one more here. Consider the graph. Which of the following are valid cycles? All right, D, C, D. No, it can't go from D to C, so that's not valid. A, C, B, B, A. Yes. You go from A to C, go from C to B, and go from B to B, and go from B to A, and starts and ends at the same place. So that's the valid one. How about this one? C to B to D. Can't go from D to C. Can't go from D to C. So that's not valid. This doesn't start and end at the same vertex, so it's not valid. This doesn't start and end at the same vertex. And this does. CCS, that's valid. Okay, B to A, all right, that's good. Yes. All right, so that doesn't look like that was quite as difficult as the depth first search challenge activity, but I hope this helps. Thanks for watching.